Hey, what are you doing?
I'm trying to reenact an important historical event.
What are you talking about?
Well, when an apple dropped on Sir Isaac Newton's head, he discovered the law of gravity.
Do you even know what gravity is?
I do. Do you?
Yeah, it's the thing that makes stuff fall.
Wait, pause game. Are we talking about gravity here?
Maybe, what does it matter?
Thomas, gravity affects everything.
Do you even know any of Newton's laws?
No.
Thomas!
Fine, then tell me everything you guys know.
When we dropped the balloons off the staircase, they fell to the ground. This is because gravity attracted the balloon and the ground to each other, therefore causing the water balloon to fall and break on the ground.
In this situation, the balloon didn't gain enough momentum to pop when it hit the ground.
Gravity, or gravitas, as Sir Isaac Newton originally called it, is the force that attracts all objects to each other.
Here is another example of when gravity takes over and pulls something closer to the ground.
When Megan lets go of the cards, they fan out and fall to the ground because gravity attracts the cards to the ground.
Sometimes the cards fell in groups, which increase their mass and weight. However, the rate at which the cards fall is always the same.
The reason that the cards fall at the same rate is because they are in a state called free fall. This is when the only force pulling the object is gravity. No matter the size of an object, it will fall at a rate of 9.8 meters per second. Do you understand gravity now?
Yeah, I think I get it. Gravity is the force that attracts an object to each other, like the balloons hit to the cement and the cards to the ground.
Yep. Now, on to Newton's laws of gravity.
We have an easy way of showing this, but we need your help in the simulation.
Okay, what do I have to do?
So we want you to sit in a spinny chair, and we're just going to push you down the hallway. You'll be at rest until Jaren pushes you, and then you'll be in motion until Sam stops you. Both Sam and Jaren are acting as the outside forces.
Is that enough of an explanation for you, Thomas?
Haha, very funny.
Are you avoiding the question?
No, Newton's first law, the law of inertia, says that an object that in rest tends to stay at rest, and an object in motion tends to stay in motion unless acted upon by an outside force.
Okay, but exactly what does that mean?
Basically, an object is going to continue what it's doing unless an outside force changes it. I was at rest in the chair until Jaren pushed me, and I was in motion until Sam stopped me.
That is what we're looking for. I think we can move on to the third law now.
Newton's third law states that for every action there is an equal and opposite reaction. Here is our first example.
Here we have a balloon that was recently inflated. When you let go of the balloon, there's an action that is followed by two different reactions. The equal reaction is the balloon flying forward through the air, while the opposite reaction is the air blowing out of the balloon and in the opposite direction.
Well, that sounds kind of cool, but do you have an example that I would care about?
I thought you'd never ask. We have one that is applicable to a lot of sports, which is a little more common than balloons.
Here we are on a basketball court watching some kids shoot around. Did you know that when you shoot a basketball, there's an equal and opposite reaction? Here we see that Megan is shooting the basketball. She is applying force on the basketball, but the basketball is also applying force to her hand.
Well, I assumed so when you started using it as an example, but I don't really understand yet. How about you guys keep explaining it?
It doesn't seem like much force is being applied to my hand, but since I feel the basketball pushing against it, we know that it's there.
So the equal reaction is the ball moving towards the basket, and the opposite reaction is the ball pushing up back against your hand, right?
That's right.
Okay, now do you understand gravity and some of Newton's laws?
Understand him? I know so much I could be him.
Well, in that case...